Okay, so we're gonna do box plots today that we didn't get to yesterday, and we did them again for fifth period. So, but today we're going to talk about measures of spread. So I've told you before, I just told you a few minutes ago, we're not going to use the range for the measure of spread anymore. Yes, sir. Yes, we're going to do box plots today. I promise. It's on the next page. Okay. So, or on the page after, I can't remember, but it's there. We will go through a box plot again, and we'll even do one in your calculator if we have time. So, but you don't have to be able to do a box plot in your calculator. You have to be able to do one on a piece of paper to show me. So, if your data is skewed, then we're going to use the median to describe the center, and what's called the interquartile range to describe the spread, not the range, the interquartile range. The interquartile range, abbreviated IQR, is the middle 50% of your data. It's the range of the middle 50% of your data, and it is the Q3 minus the Q1. So it's the third quartile minus the first quartile. So we go through and we're going to calculate those things again from some data right here. So let's try to describe this set of GPAs of some made-up students. First off, let's see if we could find the center. It's right there. I've put them in order. So finding the center, I think I'm going to go looking for the median because I think this data is skewed. And why do you think it's skewed? There's an outlier there. That point 0.5, that person who's got an F average in this school, is certainly an outlier from the C's and B's and A's. Okay? So the center I'm going to describe with the median. So let me find the median. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. So I take 13 plus 1, 14, divided by 2 is 7. Go to the seventh number, 1, 2, 3, 4, 5, 6, 7. The median is that 3.5. Okay? Now I want to find my quartiles. The lower quartile, or called the Q1 in your calculator, is the middle number of the left half of the data. So I have 1, 2, 3, 4, 5, 6 numbers to the left of the median. So I find the middle number of those. Oh, well, that would be the number right between 2.5 and 2.8. What is the number right in between 2.5 and 2.8? 2.65. Add them together, divide by 2. Yes, sir. When the median is on the value, you don't count it. If the median is between two values, then you count those values. So different computer software calculates medians and quartiles a little bit differently. So you might run some data through a different piece of software and get a different value, not usually for the median, but for the quartiles often. All right, let's find the third quartile, which is at the 3/4 point of the data, and that's the number right in between 3.9 and 3.9, which is 3.9. Okay? And I'm describing this set of data as skewed. Which direction? Skewed left. And if I want to describe the spread of this data, I'm going to call the spread of this the IQR, which is Q3 minus Q1, which is 1.25. Okay. Q3, the 3.9, minus Q1, the 2.65. Okay, remember these Q1 and Q3 and median numbers for me, and the lowest and the highest, but I think I repeat the data on the next page because we're going to do something more. And that's what? The spread, yes, that's the spread. We describe our data with the center, the shape, the spread, and we usually will mention an outlier. And so we probably should mention, if I had a little more room on the page, that there's an outlier of 0.5. Okay? Yeah. No, you just put the IQR. So it's a measure of distance. Spread is always a measure of distance, and so I don't care what two numbers made my distance. I do, but for IQR I don't. For spread I don't. I just care what their difference is. Yes. The distribution, no, range and spread. Range is a measure of spread. So the distribution would be like a table of frequencies. A histogram shows a distribution, so it gives you values and then frequencies of those values, and that's actually the distribution. Okay. Okay. So so we're calling zero point 0.5 an outlier. We have an actual formula for deciding whether something's an outlier. So a number is an outlier if it's greater than 1.5 IQRs from the third quartile or less than 1.5 IQRs from the first quartile. Let's do that in a little formula. So if I have a value that is greater than the third quartile, plus 1.5 times the IQR, which is Q3 minus Q1, or if it is less than the first quartile minus 1.5 times the IQR, Q3 minus Q1. If I have a value that meets either one of those, then it's an outlier. Okay, so let's try to figure out from this formula whether 0.5 is an outlier. So I'm going to build my fences to where if numbers are beyond these two fences, but that number will be considered an outlier. So I'm going to extend, but I'll give you back your formulas here. All right. So if I look at my data here, if I have a number that is greater than, what was Q3? 3.9? Plus 1.5 times, what was the IQR? 1.25. If I have a number that's greater than, stop it. And what is 3.9 plus 1.5 times 1.25? 5.78. Okay. If somebody had a GPA greater than 5.8, they would be an outlier. I don't have any outliers on that end, but if somebody had a GPA less than, what was my first quartile? Was that the 2.65? Minus 1.5 times my IQR. 0.78, 0.775. All right, so any value in my set less than 0.78 is an outlier. Since 0.5 is less than 0.78, 0.5 is an outlier. No, but I'm being very specific to show you how to do it. But if you want to claim something's an outlier, this is a good way to back up your claim. There are other tests for outliers.